Guys, this is Rav Nanduri. Welcome to my Learn Data with Rav series. In the last video, I was trying to explain to you guys about what is data. What is the definition of data? Data is a simple collection of numbers or facts or characters. So it's just facts and figures, right? A mere number, 25, 27, 28, 30, are just numbers. But for it to get any meaning, what we talked about is that you need to add a label on top. The label gives the meaning to data. And these numbers, let's say 25, 29, 30, 31 that I just shared, let's say that is temperature. So now you know the last week we captured 7 days temperature, and these are the numbers. And then once you know that it is temperature, you now know what was the average temperature last week, which was the hottest day, which is the coldest day. You are now able to draw inferences and knowledge out of these numbers, because now you know what the numbers mean. Without that meaning, without that label, these numbers have no meaning. Also, once you have the meaning, you also know which operations can be performed on that. The average, the minimum, the maximum. But in terms of a temperature, you never do total. What was the total temperature last week? You don't do that operation. The sum is never done on that data type or data collection. But if I were to say that these 25, 29, 30, 32 were rainfall for the last 6 months, now you know what is the average rainfall over the last 6 months. Or you know what is the total rainfall for the last 6 months, right? So given the label, the operation has changed. Our operation becomes applicable or not applicable. That's the whole attempt, that was the whole message I was trying to drive in the last 2 videos, where I talked about data is not information. So please make sure you never utter that word, that data is information. Very casually, don't do that. Data is just facts and figures. We'll go into an expanded definition of that. For now, simply stick with that. Data is facts and figures. Okay? Here is what I've done as the next step to this process, which is data is then classified into, by the way, always remember, data is a plural word. Whether it is one data element, one value, or a million values, it simply is data. So don't use datas. It's data. Now, within the data world, what are the different types of data we deal with? There is text, there is numbers or numeric, there is days, which is date format, there is the geographical numbers, because they have specific coordinates that you use to denote what those are. There are blobs, there are clops, and there are composite data types. There are many data types out there that each of these systems use and support. So what I did is, as part of this series, I collected the most popular databases and a few languages that are popular these days, and tried to demonstrate to you the fact that most of them are common across the board. There are a few exceptions between these technologies. So switching from one to another is actually very, very easy. So you never need to say, once you have your foundation, fundamental strong and understanding, you can easily switch between an Oracle to DB2, an Oracle to SQL Server, an Oracle to Snowflake. There's no difference at all in any of these. The systems, how they behave and what they can and cannot do, how the replications and other operations work within that is a different story. We will get to that. But fundamentally, all databases act very, 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 very similar. There are few nuances here and there, but in the essence, in the core of the technology, they are one and the same. Same applies to languages also. The constructs within the language might be different, but switching from one to another is very easy, provided your fundamentals, foundational understanding is good. And this attempt is to help you with that foundation. Okay, so the data types now will help you understand what are the different technologies and what they support. That's one side of the story. The second one I wanted to talk to you about is the data that we have as numbers and facts and figures has a meaning. The meaning is a label, right? The label gives meaning to a set of data collection or data elements. So this label that you attach will actually define not just the type of values that are collected here, but it will also define what can and cannot go. So which means that if it is temperature, for example, it can only be anything between 0 to 120, for example, or 150. Because human beings cannot survive, or life probably cannot survive beyond 150 degrees, let's say. So you now limit the temperature column to 0 to 150. Now that definition of temperature and you allow 0 to 150 is called metadata. So it defines what can and cannot go into that particular column, into that particular data set. So this process of defining what is the data itself, so that you're adding definition and rules into what's called metadata. We will get into the details of that. You also have the constraints you define when you define metadata. The 0 to 150 I talked about is the constraint, which means that you cannot have a number which is negative, or you cannot have a number which is greater than 150. Now, that's the constraint within which this column will operate, right? Similarly, for example, you have a first name column, and you say values between any alphanumeric values can go into this column, and the length of the column is between 1 and 100, for example. Now that 1 to 100 is the constraint you just defined on it, and you also define the fact that it has to be an alphanumeric, which means a space is not allowed. So if you try to store a name, a first name with a space in it, your database, your system will not accept it. So this level or this type of definition is called metadata. And metadata, on top of it, adds the constraints, and you also will have some business rules. Collectively, this becomes your database. Okay. Now, databases are several types. We will get into those details. But if you know these fundamentals, that data needs a definition, which is a label or a column, and the column defines what can and cannot go into it, what can be captured into that column, and the column also defines the constraints of what the column can consist of, the length-wise or definition-wise or data type-wise, and you apply some business rules and validate the data before you capture the data. This fundamental is applicable across the board, whether it is Oracle, SQL Server, DB2, whatnot. It doesn't matter. So because it is universal fact across all databases, if you know it, switching between technologies becomes easy. Having a conversation with anybody about a database or data analysis or data definition becomes easy and it's applicable across the board. That's what I'm trying to drive. As part of these foundational videos, probably we'll have 2 more where we'll talk about, the next one is what is good data. Because not all data is useful to you. So we'll talk about that in the next video. Good luck to you.